We shall commence this module by discussing the importance of expectations. As described in the last module, expectations are important in macroeconomics as they can affect the aggregate demand and output in the economy by affecting the investment demand, consumption demand and labor supply decisions of workers. There are two types of theories by which individuals form their expectations: adaptive expectation hypothesis and rational expectation hypothesis. In this module, we will study the adaptive expectation hypothesis, how individuals form their expectations under adaptive expectation hypothesis, both using the examples and mathematically. We will also study some of the major advantages and limitations of this hypothesis. After studying this module, you shall be able to know the concept of adaptive expectation hypothesis, evaluate the expected value of any variable mathematically under adaptive expectation hypothesis, evaluate its advantages and disadvantages, identify the cases where adaptive expectation hypothesis give misleading results. Let us first understand adaptive expectation hypothesis. Adaptive expectation hypothesis is given by Kagan, wherein individuals form their expectations on the basis of past behavior. In other words, a person will change his expectation of any variable if there is a difference between what he was expecting the value of variable to be last period and what it actually was in the last period. This change of expectation will be a fraction of the difference between the last period's actual value and the expected value. Thus, an individual makes his expectations about the values that a variable will in the future using the historical data. To represent adaptive expectation mathematically, consider a simple example of price level or inflation in the economy. The following equation 1 gives a simple representation of adaptive expectation. It is given as Pt to the power e minus Pt minus 1 to the power e is equals to alpha bracket Pt minus 1 minus Pt minus 1 to the power e bracket close. This is equation 1, where Pt minus 1 stands for the actual price level in the last period. Pt minus 1 to the power e is the expected price level for the last period. Pt to the power e is the expected price level for the current period, and alpha is the parameter with which expectations are revised, where 0 is less than alpha is less than 1, which states that the value of alpha ranges from 0 to 1. The equation says that a current expectation of future price level is a reflection of the past expectations and an error adjustment term. The current expectation thus is raised or lowered according to the gap between the actual price level and the expectations about the price levels in the previous period. This error adjustment parameter alpha is also called the partial adjustment factor. We will now be able to understand the adaptive expectation hypothesis clearly through an example. Let us discuss it now. Consider that the price level in the economy last period was at 10%. An individual predicting the price level for this period will expect the price level to be 10% only this period. His expectation for the current price level will be the same as the actual price level last period. Now suppose that the current price level increases to say 20%. Thus, there is a difference between what the person expected the price level to be and what it actually turned out. As a result, while forecasting the price level for the next period, he will update his belief and will expect the price level to be higher than 10% next period, but not as high as all the way up to 20%. He would expect the price level to say 15%. Thus, the individual revises his expectations for the next period, but not fully adjusts to the difference between the actual price level and the expected price level for this period. Similarly, if the current price level decreases to say 5%, the individual will update his expectation downwards. While forecasting the price level for the next period, he will expect that the price level to be lower than 10% next period, but not as low as 5%. He will expect the price level to say 8%. Thus, the individual revises his expectations for the next period, but not fully adjusts to the difference between the actual price level and the expected price level for this period. Hence, there is a sluggish adjustment to the price level when there is a difference between the actual value of the variable and the expected value of the variable. This sluggish adjustment will depend on the adjustment parameter alpha. This parameter alpha is different for different individuals and not one value of alpha can be pinned down. It is an empirical issue to estimate the value of alpha in the economy. Now, we shall discuss the advantages or attractive features of adaptive expectation hypothesis. The idea of adaptive expectation hypothesis, that is, people change their expectations for current period in response to the forecast error for the last period, has many advantages. A. Consider the example. Discuss there is only sluggish adjustment to the changes in the current price level when there was a difference in the expected price level and the actual price level for the last period. As a result, when price level changes from 10% to 20%, people do not revise their expectations all the way up to 20%. Gradually, people will revise their expectations until they get accustomed to the new higher price level of 20%. Similarly, the other way round, when price level falls, thus people can be fooled only for a short while until they fully adapt their expectations. They cannot be fooled in the long run. B. Adaptive expectation hypothesis is fairly general and can be applied to any macroeconomic variables like output, income, unemployment rate, inflation rate, growth rate of GDP, etc. Equation 1 will get molded according to the variables under the consideration. C. Adaptive expectation hypothesis always allows us to relate the expected unobservable variables to the actual observable variables. Consider equation 1. It can be rewritten in the following manner. Pt to the power e is equals to alpha Pt minus 1 plus 1 minus alpha Pt minus 1 to the power e. This has been given as equation 2. In the equation, the current expected price level is given and written in terms of last period expected price level and actual price level. Thus, the adaptive expectation hypothesis links the expected price level for the current period to the actual price level in the past period. D. Under adaptive expectation hypothesis, the expected value of a variable in this period can be written as a simple mathematical function of the past period's actual values of that variable. To understand this concept, consider equation 2, which is given. In that equation, price level is predicted for the current period. But using the same process, we can predict the price level in the last period as a function of price level that prevailed during the last period. Mathematically, the equation will look as follows. Pt minus 1 to the power e is equals to alpha Pt minus 2 plus 1 minus alpha Pt minus 2 to the power e. This is represented as equation 3, where Pt minus 2 stands for the actual price level in period t minus 2. Pt minus 2 to the power e is the expected price level for the period t minus 2. Similarly, we can formulate the mathematical equations for the predicted price levels for all the previous periods given as follows. Pt minus 2 to the power e is equals to alpha Pt minus 3 plus 1 minus alpha Pt minus 3 to the power e given as equation 4. Pt minus 3 to the power e is equals to alpha Pt minus 4 plus 1 minus alpha Pt minus 4 to the power e, equation 5. Pt minus 4 to the power e is equals to alpha Pt minus 5 plus 1 minus alpha Pt minus 5 to the power e given as equation 6, and so on. Using these equations, we can substitute the values for the last period predicted price level in the equation for the current period predicted price level. To see it, substitute the value of Pt minus 1 to the power e from equation 3 into equation 2. We get the following. Pt to the power e is equals to alpha Pt minus 1 plus 1 minus alpha bracket starts alpha Pt minus 2 plus 1 minus alpha Pt minus 2 to the power e bracket close. This is given as equation 7. Solving it, we get Pt to the power e is equals to alpha Pt minus 1 plus alpha 1 minus alpha Pt minus 2 plus 1 minus alpha square Pt minus 2 to the power e. This is given as equation 8. Now, in equation 8, substitute the value of Pt minus 2 to the power e from equation 4. We get Pt to the power e is equals to alpha Pt minus 1 plus alpha 1 minus alpha times Pt minus 2 plus alpha into 1 minus alpha square into Pt minus 3 plus 1 minus alpha cube into Pt minus 3 to the power e. This is given as equation 9. Continuing this process to the infinitum, we get the following equation for Pt to the power e as a function of past period's price level. Pt to the power e is equals to alpha times Pt minus 1 plus alpha times 1 minus alpha into pt minus 2 plus alpha times 1 minus alpha square into pt minus 3 plus alpha times 1 minus alpha cube into pt minus 4 plus alpha times 1 minus alpha to the power 4 into pt minus 5 plus and so on. This is given as equation 10. Thus, the expected value of a variable in this period can be written as a simple mathematical function of the past period's actual values of that variable. E. Adaptive expectation hypothesis economizes on the use of information. As discussed in the previous point, that current period expected value of a variable can be written as a function of the past period's actual value of that variable. A person need not to need any other information except the past period values. Past periods values are generally available in large macroeconomic databases, and hence the person forming the expectations need not to put any effort in the collection of data for forming his expectation. F. Adaptive expectation hypothesis put more weight on the near past periods than the periods that are far distant. Note that the adjustment parameter alpha lies between 0 and 1, or 0 is less than alpha is less than 1, and from equation 10 it is clear that as one moves distant in the past, its effects on the current expectation reduces. The coefficients on the price level decreases in magnitude as one moves from pt minus 1 to pt minus 2 to pt minus 3 and so forth. Thus, the most recent observations on actual price level dominate the formation of the expectations about the future price level. It again reflects that adaptive expectation hypothesis economizes on the use of information, as one need not to go back to the beginning of the time period in predicting the future values. Moving on to discuss the disadvantages of adaptive expectations. Adaptive expectations hypothesis is not free from the demerits, and under the certain circumstances it is implausible. Its own merits becomes demerits for it. Let's go over them below. A. The first advantage of adaptive expectation hypothesis was that there is sluggish adjustment to the changes in the current value of the variable of interest when there is a difference in the expected value of the variable for the last period and its actual value in the last period, and the individual will be fooled only for a short duration, but not in the long run till he gets accustomed to the new values of the variable. This advantage actually becomes a disadvantage when there is a variable which continuously rises or falls over time. Expected value of this variable will always lie below the actual value if it is rising, and expected value will always lie above the actual value if it is falling. Consider the example of price level. Suppose that alpha is equals to 0.5. So, according to equation 2 given, we get pt to the power e is equals to 0.5 into pt minus 1 plus 0.5 into pt minus 1 to the power e. This is represented as equation 11. Now, suppose that the price level increases every year by 1%. So, the actual price level in period 0 is 1%, in period 1 is 2%, and in period 2 is 3%, and so on. Since to begin with price level in period 0 is 1% and the expected price level in period 0 is also 1%, now when forming the expectations for period 1 using the information from period 0, we get the expected price level in period 1 as 1% or P1 to the power E is equals to 1%. Note that actual price level in period 1 is 2%, but expected price level is 1%, indicating that the expected value is less than the actual value. For the next period or period 2, expected price level will be 1.5% or P2 to the power E is equals to 1.5% bracket P2 to the power E is equals to 0.5 into P1 plus 0.5 into P1 to the power E minus P1 bracket close is equals to and greater than P2 to the power E is equals to 0.5 into 2 plus 0.5 into 1. Again, expected price level is less than the actual price level in period 2. Thus, when the variable is rising over time, its expected value will always lie below its actual value. Similarly, when the variable is falling over time, its expected value will always lie above its actual value. Thus, there is a systematic pattern in the forecast error which the individuals are not realizing. Thus, forming the expectations under adaptive expectation hypothesis leads to systematic under forecasting or over forecasting the true values of the variable. Thus, the advantage of this theory that an individual will be fooled only for a short duration until he gets accustomed to the new actual value is misleading in this case. The individual will be fooled in forming his expectation for the price level over the entire period until the price level is increasing or decreasing in the manner shown. Thus, under the condition that the variable of interest increases or decreases over time in a secular pattern, adaptive expectation hypothesis is not fruitful. B. Another advantage of adaptive expectation hypothesis was that it takes into account the past values of a variable in predicting its future values and hence economizes on the use of information. But suppose there is some unexpected event that might force the government to change its fiscal policy and might force the central government to change its monetary policy, then these events will not be taken care of in forming the expectations under this theory and its results could be misleading. Consider an example of the ending fixed exchange rate regime in the early 1970s towards flexible exchange regime. In United Kingdom, it was felt that a movement from fixed rate regime to the flexible exchange rate regime will make the exchange rate to fall, affecting the aggregate demand in the economy. Government knew that exchange rates are going to depreciate and it was practically informed to the public at large. There are going to be fluctuations in the aggregate demand and to counterbalance these fluctuations, government provided a boost to the aggregate demand by higher government expenditure and by increasing the money stock in the economy. In such a scenario, it will be highly irrational decision to form the expectations for the future exchange rates on the basis of its past values as predicted by the adaptive expectation hypothesis. Thus, using only the past values of the variable of interest and ignoring any major change that happens in the economy, that could affect the future values of this variable in forming its expectations is incorrect and give misleading results. C. Adaptive expectation hypothesis may give misleading results when the variable is oscillating. For example, consider an economy where inflation rate oscillates between 10% and 20% for each period. In such a scenario, under adaptive expectation hypothesis, the expected inflation rate for the next period will also oscillate between 10% and 20%. Consider the same example where alpha is equals to 0.5. We will understand the pattern of the expected inflation rate in the economy with the help of the table. The table clearly shows that individuals are expecting the inflation rate that actually never occurs in the economy and never expected the inflation rate that actually occurred in the economy. Moreover, consider the expected and actual inflation rates during period 2 and period 3, which is highlighted in red color above in the table. When actual inflation rate is falling, people are expecting it to rise. Similarly, consider period 4 and period 5, which is highlighted in blue color in the above table. When actual inflation rate is rising, people are expecting it to fall. Thus, when any variable is oscillating, adaptive expectation hypothesis give misleading results and hence does not provide a sound basis of predicting the future course of action based on the past values of this variable. D. Adaptive expectation hypothesis may not be helpful in predicting the future values of any variable whose values government can change in a manner that is unknown to the person who is forming his expectations. For example, consider that the central bank announces that it will reduce the money supply next year by 20%. Reduction of money supply by the central bank has a direct bearing on the price level in the economy. People know that money supply will be going to get reduced, but they do not know how and when it will get reduced. Will the central bank reduce the money supply by 20% in the first quarter of the year, or will it spread out this reduction by reducing the money supply by 5% in each quarter? This is completely unknown to the people who are forming their expectations on the basis of the past values of the money supply. For instance, if one expects that the central bank reduces the money supply by 5% in each quarter, the expected value of money value in the first quarter will be less than 5%. But actually what happens is that the central bank reduces the money supply entirely by 20% in the beginning of the year. Does this make people to expect that in the next quarter of year the money supply reduction rate will be greater than 5%, or does this make people to expect a money supply reduction rate of 0% in the next 3 quarters, so that over the entire year money supply has reduced by 20%? Well, it is not clear what would one expect. In such a scenario, adaptive expectation hypothesis give misleading results. Hence, under adaptive expectation, people ignore the information which might be useful in forming the expectations. Two main types of information that are ignored are: first, the way in which current value of the variable of interest is linked to its own past values, and second is the way in which the current values of the variable of interest is linked to the other variables in the economy. Hence, adaptive expectations hypothesis assumes that people behave suboptimally in forming their expectations. Now, we will summarize what we have discussed in this module. Expectations are called adaptive if they are based on the past values of the variable. Adaptive expectations are easy to calculate, simple to understand and fairly general. They can be applied to any variables whose past values are available, like inflation rate, income, unemployment rate, etc. Adaptive expectation hypothesis economizes on the use of information as it only requires the past values of the own variable. Adaptive expectations give misleading results when forming of the expectations does not take into account the information on the other variables and other events that occurred in the economy.